Evaluating logarithmic and exponential functions is super important. It's also not that hard. You just need to memorize these things. Be sure to write these down. Anything to the 0 power equals 1 as long as the base is not equal to 0. Anything to the first power is itself. Log base a of 1 is 0. Basically, remember what logarithms are saying is it's saying that this to this power equals this. Actually, why don't I write that up here for you, just as a reminder. Log base a of 1 equals 0 means a to the 0 power equals 1. Log base a of 0 is undefined. It's basically saying a to the what power equals 0. Well, if a is a non-zero number, which it has to be, nothing, there is no power that will make a to that power equal to 0, because we could have, 2 to the 4th, 2 to the negative 3rd, that would still be negative 1/8, it wouldn't be 0. If we graph this, actually, log base a of x oops, I'm doing the exponential function. Here, actually, why don't I write this down here, just so I can explain it to you. Remember, y equals a to the x looks like this. Y equals log base a of x. Looks like this. When we're over here, we're saying a to the what power gives us 0? Nothing. Everything, any value 0 or less, is undefined. So log base a of a negative number is also undefined. So let's just do some evaluating examples. We're just going to be applying the rules up top over and over. First, e to the 0. Well, e is just the natural base. It's a number like any other. Anything to the 0 power is going to be 1. Similarly, if we just have like 3 to the 0 power, well, anything to the 0 power is 1. 5 to the first power, anything to the first power is itself, so that's 5. And then natural base is no different. E to the first is just e. On the logarithm end of things, let's look at some. So let's say we've got if e to the 0 equals 1, that means that if we take the natural log of both sides, remember, these undo each other. Natural log of 1 is 0, which is exactly what we saw up here. Natural log is just log base e. So let's just say then, if we want to find, okay, number 6, log base 3 of 1. Well, we know that anything, any base, log base anything of 1 is just going to be 0. And for number 7, let's find log base 3 of 0. Well, we know that's undefined, but let's take a second and just look at that. So if log base, should have said find. So if log base 3 of 0 equals x, we're going to try to find x. Remember, we solve by doing 3 to the power of both sides, which undoes that. 0 equals 3 to the x, but not possible. No number that we can put in for x will make 3 to that power equal to 0. So we can use that just generally. Find log base 4 of 0. 4 to the what equals 0? Nothing. It's undefined. And similarly, log base 2 of negative 4 is equal to x. What could this be? Well, we know if we do 2 to the power of each side, this undoes it. 2 to the negative 4th. Oops, excuse me, negative 4. I just undid that base of 2. Negative 4 equals 2 to the what? Well, we can get 4 out of this, but this base is positive. Anything that we raise a positive base to is still going to give us a positive number. So again, this one is not possible. So that's where it comes into the rule that we were working with above. If we say something like find natural log of negative 3, we don't have to work it all out. We can just look straight at that and say it is undefined.